Hello, I'd like to take a look at this problem. It's from section 3.3, number 26. And this is a fairly routine example of a problem where we're being asked to apply these derivative rules that are introduced in section 3.3. And this uses more than one of those rules, and that's the reason I wanted to look at this with you. All right, so let's talk about the rules that are involved in this example. And I'll talk about them as we go through this, actually. So the derivative of this function, f prime of v. Well, first rule we need to use is the power rule. And the power rule says that if you want to take the derivative, I'm going to write it over here, power rule. If you want to take the derivative of x to the n power, the derivative of that is nx to the n minus 1. And if you've ever in the past learned about derivative rules, that's probably the one that you remember because you use it a lot. So that's going to give us, in this case, for that v to the 100 term, the derivative would be 100v to the 99. Okay, so we take the exponent, put it out in front, reduce the exponent by 1, and that's our new exponent. Okay, now, I didn't mention this before, but the sum rule says that if you have a sum of two functions, let's say f of x, g of x, and you take that derivative, you get the sum of their derivatives. And that's particularly important in this one because we have this polynomial made up of three terms, and so because we've got this sum, we need to have a rule here which tells us how to work with sums. Okay, and one thing you'll see as we go further in chapter 3 is some things work just like you would hope that they would, and this is an example of that. You know, if I want to take the derivative of a sum, I just get the sum of the derivatives. But other operations don't work with derivatives the way that we might predict or hope that they would. Okay, and we'll soon see that with products and quotients. Okay. But here works just like we would want it to. Now, this middle term v is something that sometimes when students are learning this kind of throws them off a little bit because they aren't sure how to apply or what rules apply, or they're just not sure. And you can think of this as the power rule. So 1 times v to the 0, and I'll say more about that as I simplify this expression. Okay, but let's leave it like that for right now. The derivative of a constant, so the constant rule says that if c is a constant, its derivative is 0. Which makes sense because remember, the derivative represents a rate of change, and so something that's constant is not changing, so it only makes sense that its derivative would be 0. Okay, its rate of change is 0. So I'm just going to write plus 0 just to emphasize that that's the derivative of that third term. But then I can simplify this expression, 100v to the 99th. I don't need to write 1 as a coefficient. It's understood. V to the 0 is 1. Okay, if you raise a variable to the 0 power, okay, that's just 1. So this is 100 v to the 99th plus 1. That's the derivative of this function here. Okay, so again, that's a pretty straightforward example of applying some of the rules in this section. These are not the only rules in this section, and they're certainly not the only derivative rules we're going to see in Chapter 3. Kind of the middle sections of Chapter 3, the next week or so of this course, involve accumulating additional derivative rules. And that's going to expand the set of functions that we are capable of working with. But that's all for this video. Thanks for watching.